Hello students, it is my pleasure to be here once again in front of you. Earlier I have given 3 courses, one on spectrophotometry, that is a 30-hour program on MOOC and NPTEL. I think then I have done one atomic absorption spectroscopy, that is also about 30 hours, and then one more course on ICP-AES, inductive coupled plasma atomic emission spectrometry, that is for about 10 years. Now I have decided that most of my MOOC courses should be about 10 years, not more than that, because one thing is because they all involve spectroscopy and atomic structure, etc. And number 2, I would like you to participate in the total understanding of the subject. That is the reason why quite often whenever I am doing a course, you will see that lot of things are, if you have taken my earlier courses, you will see that a lot of my slides are coming again in the new courses. There are 2 reasons for this. One is there are always new students appearing for the course, and many of them are engineers. Actually this course has been designed for engineers and other professionals who are not basically chemists. It does not mean that the course is not meant for chemists. It is meant for chemists also, and especially useful for the students of MSc Chemistry, MSc Environment, MSc Botany, Zoology, etc. And it is useful for the students of engineers, also engineering college students of metallurgical engineering, and then mechanical engineering, and then chemical engineering and environmental engineering. So if I have such a wide background of students, it is very natural that their background is also different, but the subject is quite vast and specific. So what happens is quite often I have to teach the fundamentals. Otherwise if I straight away go into the subject, there is always a possibility that people may lose interest because they are not able to connect with the with the possibility with the subject. Quite often if you do not connect with the subject, it leads to sort of loss of interest. And secondly, when you study the subject, it is better to understand the subject in all its entirety. Quite often for example spectroscopy, if you want to study, you have to know about atomic structure. Without atomic structure, where is spectroscopy? But quite a few engineers and professionals who are well within their middle age and other practitioners who are into the monitoring business, either in petrochemical industry or chemical industries or environmental agencies or any other environment related techniques, there is always a possibility that they might have forgotten or they might not have studied the subject altogether. Therefore, what I felt is normally it is important for us to study the subject in all its entirety, as I told you earlier. Now this topic which I have chosen, infrared spectroscopy for pollution control, monitoring, etc., actually it is a spectroscopic technique. This spectroscopic technique, obviously again it depends upon the atomic structure. Therefore, it is very important for us to study the atomic structure, and then maybe a little bit about the instrumentation, and then about the basics of spectroscopy, and then basics of infrared spectroscopy, and then instrumentation of the for the infrared spectroscopy, and then about the working of the spectroscopy, IR spectroscopy, followed by how to take the spectra, how to interpret, what are its applications, and several other aspects of infrared spectroscopy. Now, it does not mean that the whole world is composed only of infrared spectroscopy, otherwise that itself could be a very special topic by itself. Now, I have done earlier, as I told you, one on spectrophotometry, one on ICP AES, one on this atomic absorption spectrometry. Now, spectrophotometry is a molecular spectrometry course. It is also known as colorimetry, photometry, spectrophotometry, and many other related things. They are used for the different purposes. All spectroscopic techniques basically serve for the chemical analysis using instrumental methods. We do not need the wet chemical analysis. That means, like a laboratory, you do not have to take the sample, dissolve it, and then evaporate it. There are many chemical processes involved in the chemical analysis, but spectroscopy as such has got an advantage that you do not have to do much pre-preparation of the sample. Straight away you can collect the sample and do the analysis in 90% of the cases. Remaining cases, there is certain amount of chemistry involved. It is inevitable. See, basically pollution itself is a part of chemistry. Nowadays, lot of people do claim inheritance to pollution, expertise in pollution control. There are engineers, mechanical, civil engineers, electrical engineers for the maintenance of electrical equipments, and then chemical engineers want to have a big pie of that, and then there will be automobile engineers, aircraft engineers, metallurgical engineers, so many other people who are working actively in pollution control. Now, look at it from the science point of view. Where are the scientists involved in the pollution monitoring scenario? First of all, you would understand that there are chemists who form the biggest chunk of the people who are interested in the environment, and then there will be botanists, zoologists, and then physicists. They are involved. A little bit of mathematics people, they are also involved. Geologists are involved, and like that several other scientists are all involved. Biochemists, pharmacists, quite a few people are interested in the application of such techniques in the pollution control area. Now, if it was only scientists and engineers, it would have been a fairly decent group to manage. Now, you will be surprised to know that there are lawyers, then there are social scientists, then there are economists, and then there are other types of geography people. All kinds of people lay claim to the inheritance of pollution control and towards their responsibility. But again, finally, when it comes to the nitty gritty of the sample analysis, handling, and then day to day usage, etc., everybody will move away, leaving the field open for chemists. Why? Because most of the time spectral techniques as well as environmental evaluation, that is the trace or ultra trace, or it is in macro or micro, several other types of analysis which form the bulk of the environmental pollution control activities. They are all dependent upon the concentrations of the substances in the environment. Once these concentrations are known, then other things can be planned. But first of all, to know the concentration of a pollutant, we have to know that we have to feel the effect personally. then only you will say that okay, yeah, this compound is harmful, this compound is not harmful, etc. And then again there are gradations. For example, there are pollutants like cyanide. Any quantity, smallest quantity, even in ppm level, it is lethal. All of you must be remembering the Bhopal incident, where methyl isocyanate as a gas protruded at night in 1984. 15,000 people died. The concentration, that is lethal concentration, nowadays only we know. At that time, nobody knew what is the lethal concentration, how much you need to take in before the maladies effects are visible. Therefore, the analysis of the pollutants always forms some sort of basis for the assessment of pollution. And luckily, chemists are trained to do this. Chemists work on normally 3 or 4 levels of determination, and chemists are like gods, they can do anything. A good chemist will do not only chemistry, but he can contribute in mathematics, in physics, in several botany, zoology, etc., in engineering, in mathematics, in modeling, etc. But the reverse is not true. For example, a good mechanical engineer, even though he may be contributing in the field of pollution control, if you ask him something about the chemical aspect, he will draw a blank. He will not know, no, I do not know, that is not my area, something like that. So, we should always be a little biased towards chemistry, especially when we are dealing with the environmental pollution control. That is my specialization. My name is Dr. J.R. Mudakavi. I am from the Department of Chemical Engineering, Indian Institute of Science, Bangalore. And those of you who have attended my course will know that we have done lot of work on the concentration and chemicals, etc. We will repeat part of it in this, but not all, because in this course I am going to concentrate mostly on the infrared spectroscopy. But again, since we are going to work on quantitative aspects, we have to work on 4 levels, as I was telling you. One is major components, and second is minor components, okay. Third is trace components, and nowadays there is a 4th component, that is ultra trace components. So, you widely classified, we can say that major components are those components of an environment matrix. It may be an air matrix, it may be a water body, it may be a soil body, or anything, okay, hazardous waste body. So, of the such matrices, we have major component up to 1%. Okay. So, 1% and above we call them major component, because most of the such analysis can be done by wet chemical analysis. In a laboratory, you can carry the sample, do the analysis, give the result, and apply it wherever is applicable. Then comes the minor component. Now, the problem with minor trace and ultra trace components is the matrix components that are not required for analysis form the bulk of the matrix. So, it is as you go down the concentration range, for example, from 1%, let us say 0.1 to 0.2%, pollutant is there in 0.1 to 0.2%. The remaining part is a bulk of the matrix that has to be either removed or it has to be made ineffective in the technique what we are using. Now, the problem becomes more difficult when we reach the trace levels. And what are trace levels? Trace levels are in microgram per gram or milligram per kg or so many grams per ton, like that. They are all in same SI units. There is nothing hard and fast rule, but most of them are in parts per million, maybe sometimes sub parts per million. That is, parts per million means in about 10 raised to minus 6 grams. Okay, that is the weight range, 10 raised to minus 6 grams per gram, that is microgram. Now, sub microgram would be less than that. We do not go to 10 raised to minus 9 level, because that comes in the ultra trace levels. In ultra trace levels, we want to determine concentrations of pollutants in about 10 raised to minus 9 grams, that is the absolute level. So, from the absolute level 10 raised to minus 9 level, the range extends up to 10 raised to minus 12, that is from nanograms to picograms. Okay. And then sometimes you will come across areas where still lower concentrations are required for chemical analysis. That is the biggest challenge. Now, what happens? As I go down the concentration range, the matrix component looks huge, is not it? 10 raised to minus 9, remaining all is in grams. So, it is like finding needles in the haystack, but there is one difference. These needles, what we want to do is we want to catch them and count them. See, it is not just finding qualitatively the needles are there or not, but we want to know how many needles are there. That is, finding how many needle sticks are there in a big huge bunch. That is the challenge. So, the more and more we want to work at lower concentration levels, the challenges become much more insurmountable. But as I told you, chemists are fairly intelligent people. They are like gods. They think differently, they act differently, they know how to solve a problem. Given a problem, they know how to solve the problem. So, in my course, what you will be learning is this about the infrared spectroscopy application. Other techniques you can always go through my earlier NPTEL courses. I am sure they will be available at IIT Madras and IIT IISc and other database centers, but this one is the new one, and you can go through them, both all spectrophotometry, ICP and atomic absorption. And now this is the fourth one. I will try to make this a fairly simple and straightforward, because there are engineers, non-engineers, chemists and non-chemists, all are involved. So, sometimes for the people who are well trained in chemistry, it may be a little boring, because what is this, he is teaching same material, electrons, protons, etc. But I feel that it is time well worth spent, because we are not going to spend too much, we are just going to refresh our memory regarding the atomic structure, and then we will study about the fundamentals, and I also have to bring out the significance of the environment with respect to infrared spectroscopy, okay, with environmental pollution. So, apart from instrumentation, we are also going to concentrate on how to determine the organic compounds in a given matrix. So, this is the plan of the teaching. What I will be teaching you first is module 1, that is introduction, and then next module is about atomic structure, and the third is interaction of radiation with matter, because all spectroscopic techniques usually involve interaction with matter. Matter means it may be a mirror, it may be a glass, it may be an instrument, it may be an electron, many other things are involved. And then with this general introduction, we are going to spend some time on the theory of infrared spectroscopy. How does infrared spectroscopy originate? Okay. So, that will give you a firm basis on the infrared spectroscopy. Then we will study the instrumentation and finally, the application of infrared spectroscopy. Now, in this series of programs, I want you to understand this is a sort of credit based course. Okay. So, there is no compulsion for you to take the examination or assignments, but they all form part of the MOOC program as finalized by the Government of India, IITs, IISCs, and all these people are involved in the program finalization. So, I strongly urge you and go through the process of assignment and final examination. In this course, I am going to make it only something like online examination, not offline. That means, you will be writing just online examination just like you are coming for a class and finish the exam and go. Whether you do well or not depends upon how seriously you are studying the subject. Usually, we have about 40% questions from the 41, no, maybe more than 40, up to 50% questions are from the taught courses. And it will be like this, just you and I talking, and you learn the subject, same questions will come, or and you can save the material as and when I am giving the lecture. You can record it and study it and come back, and then there will be certain amount of test for intelligence. And if you are, I do not expect you all to be 100% chemists, and I do not expect you all to be 100% genius chemists or ingenious chemists for that matter, but there will be opportunity for you to exercise your brain. It is not meant for high tech engineers or high tech chemists. With ordinary background, with what I am teaching, you will do well in the course, and I expect you all to take part actively in the course, so that we all learn it well. So, once you know this subject, you are always ever ready for the challenge that comes if you are a student in your classroom, in your examination, or in your future career. If you are in an industry, if you are using, it will always come in handy. So, let us get on with this, and then what I would like to do is to spend some time regarding the introduction, because introduction again, apart from what I have told you already, there are certain other things involved in the introduction. That is why I want to spend some time. Okay. So, this is the introduction. What I wanted to tell you, this is a very general introduction. Okay. So, general introduction means we are going to talk about environment, science, technology, world, this, that, pollution, etc., etc. So, we have my first sentence, you can see that it is there, application of science and technology for improving quality of life on earth is an evolutionary ongoing process. I think you all appreciate this sentence. So, science and technology is required, it is meant for improving quality of life of ours, yours, and some other animals, maybe underwater, over water, in the forest, elsewhere, whole life as such. That is an evolutionary ongoing process, because whatever development, whatever we call as development, means changes from the existing systems. So, any change in the existing system always comes with the plus and minus part of it. Okay. So, sometimes according to Darwin, changes are meant for the fittest, and according to Lamarck, changes for the better will be carried on to next generation or future generations if the changes are beneficial to the species. A very, very interesting topic about the evolution of life. Please read up Lamarck's contribution to the evolution of life. In addition to Darwin we all know how he makes it, etc. But as and when we introduce changes in our life, there are going to be huge and profound changes will happen. For example, if I introduce car in 1780 was the first car that was produced in America, and now we have so many millions of cars on the road. Definitely it has worsened the life of the environment, it has worsened the life of the insects and many other things, and the quality of our air also has worsened, but it has also given us something to enjoy. We can travel faster, we can travel safer, we can travel without much problems. Like that, there are always changes associated with evolution and development. That is one of my main theme, and analytical science is no exception. We have developed wonderful techniques over a number of years, especially since 1960s. I am a product of 1960s to 80s, and then I have taught in the Indian Institute of Science for 36 years, and I have seen the changes coming, and preference of people changing for particular species, particular analysis, how people go about doing it, etc. Okay. So, since last 50 years, as I was telling you, the pace of adoption of science and technology has been increasing at breakneck speed. I think all of you remember your mobiles, right. So, in 1990s mobiles were introduced, just very primitive models. Nowadays I call a simple mobile as Gandhi engineering. Mahatma Gandhi used to say that we should do more with less. Now the mobiles have become smaller, they have become thinner, they have become more complex, but you can do many things with the mobiles, is it not? There are mobiles which can do internet for you, mobiles which can capture your image, they can capture your selfie image, okay. They can send messages, talk to somebody on the phone, collect data, do literature survey, and then many other things. There must be about 6 to 8 million applications of software apps. I think all of us are familiar, but just imagine a case of about mobiles about 10 or 15 years before. They look like primitive mobiles, isn't it? So, this breakneck speed of change in the environment or in our life is occurring very fast, even for our comfort. So, the adoption of science and technology for human comfort are also increasing. There is a requirement of food, there is requirement of clothing, requirement of housing, low cost housing, high cost housing, all kinds of housing, medicine, travel, entertainment, many of these. So, it is a very visible process basically, right. So, however, the same advances can be used to solve myriad problems confronting humanity. We can cite several examples: green revolution, white revolution, and then include medicines for diseases, pollution control. Several other disciplines have emerged over a period of time to solve the problems of the society, which may be of recent origin or may not be of recent origin. For example, many of us are under the impression that the pollution problems are all man-made. No, not at all. Okay. Now, if you think it is only the man-made problems that we are facing, it will be an absolutely wrong conception. For example, there is a lot of sun's heat and other things are there, which have made changes in the environment of the earth. Several thousands of dinosaurs and other life forms have formed and extinguished. So many cold climates have come in, and so many changes have taken place. So, it has no meaning to say that everything is of anthropogenic origin. That is not right. So, look at it like this: fundamental sciences such as atomic and molecular structure, they have made rapid strides in the last century. Okay. This I have been emphasizing because the most of the understanding of our nature comes from the understanding of the chemistry. Okay. So, this currently most of our knowledge comes from developments since last 200 years. People have been trying to record or determine, understand the structure of the atom, structure of molecules, all those things since 1800, yeah, sort of. And then currently we are able to understand the atomic structure, molecular structure of the elements and compounds, and in terms of every electron that is involved in the building of the molecules and elements. Even though we do not see the electrons, we can still predict what it is made of, how the electrons are arranged, etc. And we can predict nuclear structure, we can play with the nuclear structure, do fission, do fusion, do many other things. When they make them undergo chemical reactions, produce energy, many other things. So, atomic and molecular spectroscopy again is part of the development of our understanding of the atomic structure. So, it is a science which is an offshoot of the structural changes occurring during electronic and nuclear transitions. So, all the basis of spectroscopy is the changes in the electronic and nuclear structure. Sometimes we are solely dependent upon the electronic structure, electronic transitions, electron escaping, ionization, and all those things are there. And sometimes we expect nuclear changes to occur, alpha, beta, gamma radiation changes, etc. They are also there occurring during the electronic and nuclear transitions. So, over the years spectroscopy itself has undergone changes quite a lot during electronic and nuclear transitions. Our spectroscopic technology or knowledge has grown into a very powerful tool for the identification and quantification of chemical compounds. The same can also be used to follow the progress of chemical reactions also. This is one advantage of how we are going to improve the quality of life. Whenever I want to carry out a chemical reaction, we want to know how far a reaction proceeds, So, how do you do that? Most of the time we have been trying to take the sample, analyze it, etc. But spectroscopy has made the job very simple. You just take a small sample, put it in a spectrophotometer or spectroscopic tool, it will give you the progress of the reaction. Okay. So, we will continue our discussion in the next session. What I wanted to tell you in this case is that the spectroscopy is part of our life today. It is useful for myriad programs. Okay. My next slide, I am going to talk about environmental pollution.